This is a practice paper for the Edexcel Higher Tier 2022 Paper 3. It is based on the advanced information, so the topics in this paper will be the same as the topics in the Paper 3 exam this summer. Here we've got the formula page that we're being given. So some of these formulas may be useful in this exam. We can refer back to it if we need to. Okay, question 1. So we've got a frequency polygon question. The frequency table shows the heights in centimeters of some tomato plants. And we need to draw a frequency polygon. In a frequency polygon, we plot the midpoint against the frequency. So midpoint against frequency. The middle of 140 and 150 is 145. So it's 145 against 7. So 145 and then 5, 6, 7. Halfway between 150 and 160 is 155, 155. So 155, 10. 155, 10. We're going to have 165, 15. $175, 19. So 2 little boxes down from 20. Each 2 little boxes is 1. And 185, 9. Once we've plotted our points, we need to join them up using a ruler. So we get a ruler and we join up. We're joining up using straight lines, and that will complete our frequency polygon. Question 2. Banana Computers sold 19.3 million computers in 2017. In 2018, they sold 18.2 million computers. Work out the percentage decrease in the number of computers sold. Give your answer to 3 significant figures. So whenever we're calculating a percentage decrease, any percentage change, we do the change over the original times 100. So for our percentage change, or for the amount it's changed, we can do the new take away the old. So that's 18.2 take away 19.3. If you do these the other way around, it will just mean instead of getting a negative answer, you get a positive answer. Over the original, so that's the 2017, that's the 19.3. Then times 100. So change over original times 100. Type it into the calculator. So 18.2 take away 19.3 over 19.3, and then times by 100. So I've got negative 5.699. So to 3 significant figures, 1, 2, 3. The next numbers are 9, so round up. So it's negative 5.70%. And because we were asked what the percentage decrease is, we don't need the negative sign. So we don't need to write the negative sign. We can just write 5.70. Question 3. The value of a house increased by 6%. The house then had a value of 265,000. Work out the value of the house before the increase. So this is a reverse percentage question. The original value of the house is what we're working out. We'll call that X. Then we added on 6%. To add on 6%, well, if we add on 6%, we'll have 100% plus 6%, which is 106%. So if I wanted to add on 6% to x, I would multiply it by 106%, but I'll write that as a decimal, 1.06. So something times 1.06 equals 265,000. So we've added 6% onto x, and that's given us 265,000. We want to know what x is, so we divide both sides by 1.06. So 265,000 divided by 1.06 is 250,000. So that's 250,000. Question 4. S equals ut plus half at squared. And we've got u is -5, a is 4, t is 3. Work out the value of s. So we're going to substitute these in. So s is u times t, ut, plus half times a t squared. S equals ut plus half at squared. Then we can just type this into the calculator. So -5 times 3 plus half times 4 times 3 squared. So that's 3. S is 3. Part B, make a the subject of s equals ut plus half at squared. So that means we need to get a by itself. Make it a equals something. So the first thing we can do is get rid of ut. And at the moment, it's added to half at squared. So to get rid of a plus, we do the opposite. So take it away. So we're taking ut away from both sides. So s minus ut is equal to half at squared. I'm going to get rid of the half next. So to get rid of the half, I'm going to double both sides. So multiply both sides by 2. So I'm going to have 2 times all of the left side. So 2 times all of s minus ut is equal to at squared. And to get a by itself, at the moment it's multiplied by t squared. To get rid of a times, we do the opposite of timesing, we divide. So divide both sides by t squared. And a is by itself. A is the subject of the formula. We could expand this bracket. That will give us 2s minus 2ut on top over t squared. Either way, it's a correct answer. Question 5. There are 120 people in a school canteen. 40% of the people in the canteen are Year 11 students. The number of Year 11 students in the canteen is 3 times the number of Year 10 students. The rest of the people in the canteen are Year 9 students. The number of Year 9 students, the ratio of Year 9s to Year 10s is n to 1. Work out the value of n. So let's go through this, working out as we go. So 120 people, 40% are Year 11. So 40% of 120. So 40%, but of we write times 120 is 48. So 48 Year 11s. The number of Year 11 students is 3 times the number of Year 10. So the number of Year 11s divided by 3 will give us the number of Year 10s. So that's 16. So 48 is 3 times 16. The rest of the people are Year 9s. So 120, take away the year 11s, take away the year 10s, is 56. So we have 56 year 9s. The number of year 9s to the number of year 10s is n to 1. So the ratio of year 9 to year 10. So we've got 56 to 16. And we've got to write it in the form n to 1. So we're going to divide both sides by 16. So we'll get 1 for the year 10s. 56 over 16 is 7 over 2, or 3.5. I'll leave it as 7 over 2. So n is 7 over 2. Question 6. Amy drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles per hour. From this point, it takes Amy 3 hours and 5 minutes to complete her journey. What was Amy's average speed for the whole journey? Give your answer correct to 3 significant figures. So we've got 2 parts to our journey. So we've got the first part is 165 miles at a speed of 60 miles per hour. And for the second part, we know it's 3 hours and 5 minutes. We need to know the average speed for the whole journey. So speed is equal to distance divided by time. So we want total distance divided by total time. And we know the total distance. It's going to be 300 miles. What we don't know is the total time. We know the second part is 3 hours 5 minutes, and we can work out the first part. So again, speed is distance over time. To find time, if we times both sides by time, speed times time is equal to distance, and divide both sides by speed. Time is distance divided by speed. So for the first part of the journey, the time is 165 divided by 60. So it's 11 over 4, 2.75, but this is in hours, it's miles per hour. So 2.75 hours. So 2 hours and 3/4 of an hour. If we press our time button, it will tell us that's 2 hours and 45 minutes. So now we can work out our total time. Which is going to be 2 hours 45 minutes plus 3 hours and 5 minutes. So the hours, 2 and 3 make 5. 45 and 5 make 50. So 5 hours and 50 minutes. That's our total time. Now we can either change this into hours or use the time button on our calculator. So if we were to change this into hours, we'd say 50 minutes is equal to, and in an hour there are 60 minutes. So it's 50 over 60 hours, or 5/6 of an hour. So we could say we've got 5 and 5/6 of an hour, and we can work 5/6 out, which is 0.83 recurring, or just 5/6, add it to 5, so 5.83 recurring hours. So we could use that, or the alternative, which is a bit easier, use the time button. So the average speed is our total distance, which was 300, divided by the time. So if you just put 5 hours and 50 minutes, so 300 over 5 hours 50 minutes, and there's our answer. So 51.4, 3 significant figures, 51.4 miles per hour. Question 7. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same potatoes cost £1.85 for a 2.5 kilogram bag at a supermarket. Where are the potatoes better value, the farm shop or the supermarket? So to compare these, we need to make them the same. And the easiest way to do this, if we times 2.5 by 5, we would get 12.5. So it's £1.83 for 2.5 kilograms at the supermarket. So if we times this by 5, we will find out how much it costs for 12.5 kilograms. So 1.83 times 5 is £9.15. So £9.15 for 12.5 kilograms. So that's the supermarket. At the farm shop, it was £9 for 12.5 kilograms. So the farm shop is better value. £9 is less than £9.15. Question 8. ABCD is a trapezium. Calculate the area of ABCD. So the area of a trapezium, this formula is in the formula sheet we're given, is half times A plus B times the height. Half the sum of the parallel sides. So these two are the parallel sides, AD and BC. Half of A plus B times the height, which is a distance between them, which is 15. The perpendicular distance between them is 15. So if these are A, B, and H, we know A and H, but we don't know B. So half of 12 plus B times 15. Now we need to work out this length so we can find the area of this trapezium. And we can do that by drawing a straight line here. And we make a right angled triangle. So we've got a right angled triangle here. It's a Pythagoras question. So Pythagoras says, again this is in the formula page, a squared plus b squared equals c squared. The two shorter sides squared and added together are equal to the longer side squared. So the hypotenuse here is 17. This length here is 15. It's the same as AB. So this length is equal to AB. It's 15. And we can work out this length here. We'll call this one x. So x squared plus 15 squared equals 17 squared. So if we take 15 squared away from both sides, so 17 squared take away 15 squared is 64. So x squared is 64. So square root both sides, and we find that x is 8. So this length is 8. That means B must be 12 take away 8. So the whole of AD is 12. This part of it is 8. So the missing part is 12 take away 8, which is 4. So B is 4. So we've got half of 12 plus 4 times 15. So let's type this into the calculator. And we get 120 centimeters squared. Question 9. Given that 81 times root 3 equals 3 to the power of n, find the value of n. So we need to rewrite 81 and root 3 as powers of 3. 81 is 3 to the power of 4. 81 is, well, it's 9 times 9, and each 9 is a 3 times 3. So 81 is 3 to the power of 4. Root 3 can be written as 3 to the power of a half. A square root can be written as a power of a half. So what we have here is 3 to the power of 4 times 3 to the power of a half. When we multiply indices, we add the powers. So we've got 3 to the power of 4.5, or 4.5, or 9 over 2. Any of those, 3 to the power of, I'll put 4.5. So n is 4.5. Or 9 over 2. Question 10. There are 5 starters, 6 main courses, and X desserts in a restaurant. Riley says there are 130 different ways of picking, choosing a starter, a main course, and a dessert. Could Riley be correct? You must show your working. So the number of options there are, the number of ways of picking is 5 times 6 times x. It's the product rule for counting. 5 times 6 times x. Can that equal 130? So let's say it does, and we'll find out how many desserts there are. So 5 times 6 times x, we can write that as 30x. To get x by itself, we'll divide by 30. So 130 over 30. So 130 over 30 is, well, 4.3 recurring. So can there be 4.3 recurring desserts on the menu? No. So Riley cannot be correct. There has to be a whole number. Of desserts. Question 11. The line AB passes through the points -2k and 4, 8. The gradient of AB is -2. Work out the value of k. So the gradient is the change in the y divided by the change in the x. Gradient is change in y over change in x. So we can call these x1, y1, x2, y2, and substitute them in. So the gradient is -2. So -2 is equal to 8 minus k, the change in the y's, divided by the change in the x's, 4 take away -2. And 4 take away -2 is 6. The change in the x's is 6. Now we can multiply both sides by 6 to get rid of the fraction. So negative 12 is 8 minus k. Then I will plus k to both sides to make the k positive. So k minus 12 is 8. Then plus 12 to both sides. So k is 20. Question 12, expand and simplify. So we've got triple brackets. To expand these, we're just going to take 2 of the brackets and expand them, and then we'll expand again afterwards. So let's expand these first 2 brackets, and I'm going to put the expansion of that into another bracket. So x times x is x squared. X times negative 3 is negative 3x. 5 times x is 5x, and 5 times negative 3 is negative 15. Then that's still multiplied by the 2x minus 1, still multiplied by that third bracket. I can collect the like terms for what is now my first bracket. I've got negative 3 plus 5, which is 2, so x squared plus 2x minus 15 times 2x minus 1. So I've expanded the first 2 and simplified them. Now I'm going to expand again. So I'm going to multiply all 3 terms in the first bracket by both of the terms in the second bracket. So x squared times 2x, 2x cubed, x squared times negative 1 minus x squared. 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. Negative 15 times 2x, negative 30x, and negative 15 times negative 1 be a positive 15. So now I just need to collect the like terms again. So I've got 2x cubed minus 1x squared plus 4x squared will be 3x squared. Negative 2x take away 30x, negative 32x, and plus 15. So that's my answer. 2x cubed plus 3x squared minus 32x plus 15. Question 13. So we've got A, the vector A is negative 2, 3. So left 2 up 3. B is 5, negative 1. So right 5 and down 1. Right as a column vector, A plus B. So we just add the tops and add the bottoms. So if we go 2 to the left and then 5 to the right, we've gone 3 to the right in total. Negative 2 and 5 make 3. And if we go 3 up and 1 down, we go 2 up in total. 3 plus minus 1, 3 minus 1 is 2. 2a minus b, so we do a twice and then we take away b. So if I double a, this will be 2a, negative 4, 6, that's 2a, and we're taking away a b. So negative 4 take away 5 is negative 9, and 6 take away a negative 1. When we take away a negative, we add. So 6 plus 1 is 7. Question 14. A car's value is decreasing by X% each year. The car's value will decrease by 60% in 6 years. Work out the value of X. Give your answer to 2 decimal places. So if we start with 100% and we decrease it by 60%, that means we've got 40% left. So we need to work out what percentage change each year we need to go from 100% to 40%. So we can say 100. We don't know the exact numbers here, but we can use the percentage values. So 100
times some multiplier, and I'm going to call that y, 6 times for 6 years. So 100 times y to the power of 6 is going to equal 40. So 100, our starting amount, times our multiplier 6 times to the power of 6 is going to give us 40. If we divide both sides by 100, we get that our multiplier to the power of 6 is 0.4. Now to find our multiplier, we need to do the 6th root of both sides. The opposite of a power of 6 is the 6th root. So our multiplier will be the 6th root of 0.4. And on our calculator, we're going to have a button to do the 6th root. So on this calculator, it's Shift and then this power button. So we're going to put the 6 above the root and 0.4 inside the root, and we get 0.85837 and so on. So our multiplier is 0.85837. That's our multiplier. That's not our percentage that we were decreasing by. So if we change this into a percentage by multiplying it by 100, that means it's 85.837%. So each year we have 85.837% of what we had the previous year. And to find the percentage change, you can do 100%, take away that. So I'm timesing by 100 to change it to a percentage, and doing 100 minus the answer. So that's 14.16%. So that's 14.16%. Every year we're decreasing by 14.16% to get a 40%, to get a 60% decrease in 6 years. So we take off 14.16% every year for 6 years, and that will get us down to 40%. We can check our answer by doing it backwards. So 100 times our multiplier, 0.85837 to the power of 6 gets us down to 40% of the original value. Question 15. A and C are points on the circumference of a circle with center O. BC is a tangent to the circle. Angle CAB is 29 degrees. Find the size of angle ABC. That's this one. You must show you're working. So what we can probably use is that a tangent, so it's not drawn to scale, a tangent meets a radius at 90 degrees. So this is a 90-degree angle here. We can also use two radiuses are going to make an isosceles triangle. So this triangle here, AOC, so AOC is an isosceles triangle. So that means OCA is also 29 degrees. The angles at the base of an isosceles triangle are equal. So we can use this big triangle now, this whole triangle, ABC, and say angles in a triangle add up to 180 degrees. So angle CAB
angle ACB, so ACB is 90 plus 29. So that was tangent meets radius at a right angle. So ACB is 90 and 29. That's 119 degrees. We know we've got a 29 here. So angles in the triangle add up to 180 degrees. So 180, take away this, this, and this will give us x. So 180, take away 29, take away 119. Is 32 degrees. And that's because angles in a triangle add to 180 degrees. Question 16. The two triangles in the diagram are similar. There are two possible values of x. Work out each of these values and state any assumptions you make in your working. So we are told that we've got similar triangles, but we're not told which side corresponds with which side. So either AB could correspond with AC, or AB could correspond with AD. So we've got ABE. Let's have a quick sketch. So ABE, 6 and 5. And we've got ACD, ACD. So AC is 9, 5 plus 4. And AD is 6 plus x. So either AB corresponds with AC, so if AB corresponds with AC, if AB corresponds with AC, then the scale factor will be times 9/5. So to go from 5 to 9, we can times, scale factor is times 9/5. So AD will be 6 times 9/5, which is 10.8, and x is 10.8, take away 6, which is 4.8. So if AB corresponds with AC, we've got that. If AE corresponds with AC, then the scale factor will be times 1.5. 6 times 1.5 is 9. So I could write times 9/6 or times 3/2, which is the simplified version of it. So then AB would go with AD. So AD would be AB, which is 5 times 1.5, which is 7.5. And x would be 7.5 take away 6, which would be 1.5. So it's either 4.8 or 1.5, depending on which side is an enlargement of which side. Question 17. We've got 3 plus, and then in a big bracket, x plus 4 divided by x squared minus 16 over x minus 5. So that simplifies into ax minus b over cx minus d, where a, b, c, and d are integers. So let's start simplifying this. So I'm going to keep my big bracket for now. So when we divide by a fraction, we can flip it over and change it to a multiplication. So dividing by a fraction is the same as timesing and flipping over the fraction. And I'll keep everything else the same for now. So I'm going to change x plus 4 into x plus 4 divided by 1. So I'm just changing it into a fraction just to make it clear when I'm timesing them, I times the top and times the bottom. What I will also do at the same time, I'm going to factorize x squared minus 16. So x squared minus 16, it's the difference of two squares. It factorizes to x plus 4 times x minus 4. So if I expanded these brackets, I'll get x squared minus 4x plus 4x, which adds up to nothing, minus 16. So whenever you have two square numbers, we can do this. So x squared minus 16 is x plus 4 and x minus 4. X squared minus 49 is x plus 7 and x minus 7. X squared minus y squared is x plus y, x minus y. So that's the difference of two squares. We're going to use that to factorize this. So x plus 4, x minus 4. So now I'm going to times the top and times the bottom. So I've got 3 plus, then in my bracket, I now have x plus 4 times x minus 5 on the top, and 1 times x plus 4 times x minus 4 is just x plus 4 times x minus 4. Now for this fraction, I've got x plus 4 on the top and x plus 4 on the bottom. We can divide top and bottom by the same thing and keep the fraction equivalent. So I divide top and bottom by x plus 4. So now I have 3 plus x minus 5 over x minus 4. I want to add these two together. So I'm going to think of 3 as 3 over 1 at the moment. And to add fractions, I need to make the bottom numbers the same, make the denominators the same. So I'm going to times top and bottom of 3 over 1 by x minus 4. So that will give me 3 times x minus 4 over 1 times x minus 4, which is just x minus 4. And that's added to x minus 5 over x minus 4. I'm going to put x minus 5 in a bracket. That doesn't matter so much because I'm adding, but if I was taking away, I wouldn't want to forget to take away one of the terms. Now the denominators are the same, so I can add them. So I've got x minus 4 on the bottom. I've got 3 times x minus 4 plus x minus 5 on top. I'm going to expand these brackets. So 3x minus 12. And then this is timesing by 1. It's just going to stay the same. Plus x minus 5 over x minus 4. And finally, collecting the like terms on the top, 3x and 1x make 4x. Negative 12 take away 5 is negative 17 over x minus 4. That's my answer. Question 18. The diagram shows a triangular prism. CD is 20 centimeters. AD is 30 centimeters. And angle, it should say FDC, angle FDC is 35 degrees. Calculate the size of the angle, calculate the size of the angle the line AF makes with the plane ABCD. So it's the between the line AF, so A to F is this diagonal, and the plane ABCD, that's the base. So if we draw another diagonal here from A to C, we can make a right angle triangle, and the angle between AF and the plane ABCD is this angle here. So we've got another right angle triangle. And we've got an angle X we need to find. So we need to find two bits of information for this red triangle we've got here. We've got a right angle here. So we've got a Pythagoras question to find AC. So triangle ACD, we can use Pythagoras to find AC. So in triangle ADC, we've got a right angle at ADC. We know D to C is 20, A to D is 30, so we can find A to C using Pythagoras. So A squared plus B squared equals C squared. 20 squared plus 30 squared is going to be AC squared. So 20 squared plus 30 squared is 1,300. So AC is going to be the square root of 1,300, which will put us 10 root 13. Centimeters. So we know A to C now. We can also use this 35 degrees and this triangle CDF to find CF. So we'll have another triangle CDF. So we've got CDF, a right angle at C. 35 degrees is angle FDC. D to C is 20 centimeters, and we want to find C to F. So we can use SOHCAHTOA. We've got a right angle triangle, and we've got one angle and one length we know, so we can use SOHCAHTOA to find another length. So we have the opposite, which is CF, the adjacent, which is CD. With the hypotenuse we're not using, so we want O and A, so that's tan TOA. So tan, I'll put tan theta, tan with the angle, is the opposite divided by the adjacent. So tan 35 is CF over 20. So CF timesing both sides by 20 is 20 times tan 35. So 20 times tan 35 is 14.0. So C to F is 14.0 centimeters. So now we know C to F is 14.0. We know A to C is 10 root 13. So now we can find X. We've got two lengths and we're finding an angle. Again, it's a SOHCAHTOA question. So Pythagoras is when we've got all three lengths. We know two and we're finding the other one. And SOHCAHTOA is either two lengths finding an angle, or an angle and a length finding the other length. So let's put the information down for our triangle ACF now. So A to C to F. So we have A, C, F. C to F was 14.0. A to C was 10 root 13. And we're finding the angle CAF. So this one. So we're not using the hypotenuse again. It's the opposite. Opposite the angle is 14.0. And the adjacent, in between the angle and the right angle, is 10 root 13. So tan theta, or tan x, is O over A, 14.0 over 10 root 13. So we can use that answer button in the calculator. Answer over 10 root 13 is 0.388. That's tan x. To get tan away from x, the opposite of tan is the shift tan, arctan. So shift tan, the answer, 21.2 degrees. Question 19. The table shows information about the time in seconds taken for some people to run a 100-meter race. So we've got the times and the frequencies. Part A says use the information on the table to complete the histogram. So we've got a histogram. On a histogram, we don't put the frequency on the vertical axis. We put something called frequency density. So the height of the bars is not the frequency. We find the frequency on a histogram by working out the area of the bars. So the area of the bar has to be proportional to the frequency. So the simplest way of doing that is making the area equal to the frequency. So the area is the frequency. And if the area is the frequency, if this is the area, we can find the frequency density by doing the area of the bar divided by the width of the bar. So this one goes from 10 to 12. So it's got a width, so a class width of 2. So if it's got a base of 2, a class width of 2, and the area is 6, we can find the frequency density by doing 6 divided by 2. 6 divided by 2 is 3. So if it's got a base of 2, a height of 3, 2 times 3 makes 6. The area is 6. So frequency divided by class width is going to be our frequency density. So 12 to 13 is 1. So it's 1 wide. It's got an area of 21. 21 divided by 1 is 21. Again, 13 to 14 has got a width of 1. So its area is 23. Its height must be 23. We don't know for 14 to 16. That will be on the diagram. And 16 to 20 is 4 wide. 8 divided by 4 is 2. So it must have a height of 2. So the 16 to 20 bar is already drawn on, and we know its frequency density is 2. So this must be 2, and we can use that to fill in the rest of the scale. So every 2 little boxes is 1. So 3, 4, 5. So each. So 5, 10, 15, 20, 25. So let's complete these boxes now. So time 10 to 12 seconds has got a height of 3, a frequency density of 3. So 10 to 12 goes up to 3. (12 to 13 goes up 21. Up to 21. (13 to 14 goes up to 23. And then that's the histogram completed. The histogram is completed, all the bars are drawn. Part B, use the histogram to complete the table. So we need to know the frequency for the 14 to 16 bar. So the frequency is the area. So it's 2 wide, got a base of 2, from 14 to 16 is 2. A height of 21. So base of 2, height of 21, the area 2 21s, 42. Question 20. So f is root g over h. G is 12.7, correct to 3 significant figures. H is 9.294, correct to 3 decimal places. By considering bounds, work out the value of f to a suitable degree of accuracy. Give a reason for your answer. So we need to work out the upper bound for f, the biggest thing f can be, and the lower bound for f, and see what they can both round to. See how accurate we can make them, that they give us the same answer. We're going to get the upper bound for f. So upper bound for f is going to be square root of the upper bound for g. When we want a bigger answer, we divide by a smaller number. So divided by the lower bound for h. So if you divide by 2, you get a bigger answer than if you divide by 10. So we want the lowest thing h can be to divide by, and that will give us a bigger answer. For the lower bound for f, we're going to do the square root of the lower bound for g divided by the upper bound for h. So let's work out these bounds. So for g, we've got 12.7. So with 3 significant figures, the one up is 12.8, the one down is 12.6. So the lower bound is halfway in here, 12.65, and the upper bound is 12.75. For h, we've got 9.294. One above is 9.295. The one below is 9.293. And our lower bound is halfway, so 9.2935. And our upper is 9.2945. So substituting these in, the upper bound for f is square root of upper G, 12.75, divided by lower h, 9.2935. And the lower bound for f is the square root of the lower G, 12.65, divided by upper h, 9.2945. So let's just write these in the calculator. 12.75 over 9.2935. So that's 0.384. That should be enough. I'll put a 2 as well. So I'll go to 4 decimal places. We're unlikely to need them. And then for the lower bound for f, it's 12.65 over 9.2945. 0.3827. Okay, so we've got our upper bound and our lower bound. What do they both round to? So they're not the same to 4 decimal places. We can see we've got 2 different numbers here. To 3 decimal places, we'll have 0.384 and 0.383. So they're not the same, but to 2 decimal places, they're both 0.38. So both round to 0.38 to 2 decimal places, or 2 significant figures. Question 21. Here are 2 right-angled triangles. Given that cos A equals cos B, find the value of x. So cos theta is ca, adjacent over hypotenuse. So for our first triangle here, the adjacent is x and the hypotenuse is 4x plus 3. And for our second one, the adjacent is 3x plus 2 and the hypotenuse is 27x plus 4. So cos A equals cos B. Cos A is x over 4x plus 3. It's the adjacent over the hypotenuse. And cos B is 3x plus 2 over 27x plus 4. Again, adjacent over hypotenuse. So now we've got an algebraic fraction question to solve. So let's get rid of the fractions first. So if we multiply both sides by 4x plus 3 and multiply both sides by 27x plus 4, we will get x times 27x plus 4 is equal to 3x plus 2 times 4x plus 3. So now we've got brackets to expand. So let's expand them all. So x times 27x, 27x squared. X times 4 is 4x. 3x times 4x is 12x squared. 3x times 3 is 9x. 2 4x's are 8x. And 2 3's are 6. Collecting the like terms. So I'm going to leave my left side as it is. I'm just going to add up my 9x and my 8x for 17x. Now I've got a quadratic. I'm going to solve it by making it equal to 0. So take 12x squared away from both sides. 27 take away 12 is 15. I'm going to take away 17x from both sides. So 4 take away 17 is negative 13. And take away 6 from both sides. So now I've got it in the form ax squared plus bx plus c equals 0. I've got to solve this quadratic now. I could try and factorize, or use the quadratic formula. Either one would be absolutely fine. So if we're using the quadratic formula, a is 15, b is negative 13, c is negative 6. Just trying to figure out if it factorizes. So I'll do it both ways. I'll try and factorize it, and I'll use the quadratic formula. So x is equal, for the quadratic formula, to negative b plus or minus the square root of b squared minus 4ac all over 2a's, 2 times 15. So we can type this into the calculator. Let's just have a quick check on our formula page. So on the formula page, we've got the quadratic formula given to us. So we don't have to remember it. We can just find a, b, and c and substitute them in. So on the calculator, fraction button first, and then I'm using brackets wherever I've substituted in for a letter. So this is for the plus. So I've got 6/5. Or for the minus, so I'm going to go back in and change the plus to a minus, minus 1/3. I couldn't have a length as minus 1/3, so I have to say x can't be minus 1/3, so x must be 6/5 or 1.2. So it would have factorized. I will show you that as well. So a times c, 15 times negative 6 gives me a negative 90. And then what multiplies to make 90 and adds to make 13? So 190, 2 45s, 3 30s. It's not in the 4 times table, because that would be 4 times 22.5. 5 18s. And that will give me my negative 13. So I can rewrite 15x squared minus 13x minus 6 as 15x squared plus 5x take away 18x minus 6. So instead of negative 13, I've got plus 5 minus 18. It means the same thing. I've uncollected the like terms. So what can I factorize out of the first two terms? That will be my first term. So they've both got a 5 and an x in them. So 5x. So 5x times what makes 15x squared? 5 times 3 makes 15. And x times x is x squared. 5x times what makes 5x? That's a 1. Something times 3x is negative 18x. 3 times a negative 6 will be a negative 18. And negative 6 times 1 is negative 6. So then either my first bracket is 0 or my second bracket is 0. And then that will give me the same answers, 6/5 and minus 1/3. Question 22. Solve algebraically the simultaneous equations. X squared minus 3y squared equals 13 and 2x plus 3y equals 4. So when we've got squareds in our simultaneous equations, we're going to use the linear one, the one without squareds in, to substitute in. So we're going to solve them by substitution. So I'm going to make my linear one, the one with just x's and y's in, either x equals or y equals. So if I make it x equals, I'm going to take 3y away from both sides. So 2x equals 4 minus 3y, and then divide by 2. So 4 minus 3y over 2 is equal to x. So I've rearranged my linear one, so it's x equals, and then I'm going to substitute this 4 minus 3y over 2 in for x in my top one, in my one with the squareds in. So instead of x squared, I'm changing x into this, so it's 4 minus 3y over 2 squared minus 3y squared equals 13. So now it's all in terms of y. There's no x's left, I've substituted in for them. So I've just got y's, and now I'm going to solve this. So I'm going to expand these brackets first. So I've got 4 minus 3y over 2 times 4 minus 3y over 2 minus 3y squared equals 13. When I multiply fractions, I times the top and times the bottom. So the bottom of this fraction is going to be 2 times 2, which is 4. And the top is like expanding brackets. Well, it is expanding brackets. So 4 times 4 is 16. 4 times negative 3y will be negative 12y. Negative 3y times 4 is negative 12y again. And a negative times a negative is a positive. 3y times 3y is 9y squared. I'm going to collect those like terms. So I've got minus 12y minus 12y. So minus 24y. Now I want to get rid of my fraction. So to get rid of dividing by 4, the opposite of dividing by 4 is multiplying by 4. I need to multiply everything by 4. So I'm going to get rid of the divide by 4 on this part, but I still need to multiply both of my other terms by 4. So multiplying by 4 gets rid of this divide by 4. I'm multiplying the whole equation by 4. So I need to multiply my negative 3y squared by 4, which will give me negative 12y squared, and multiply my 13 on the other side by 4, which will give me 52. Now I'm going to collect the like terms. So I've got 16 minus 24y. I've got 9y squareds. Take away 12y squareds, which is a negative 3y squared. I've got a quadratic. I'm going to solve it by making it equal to 0 again. So I'm going to move everything over to the right this time. So I've got 3y squareds plus 24y's. I've got 52 take away 16, which will be 36. So equal to 0. All of my terms are in the 3 times table, so I can divide the whole equation by 3. And this factorizes, so it's a y in both brackets. What multiplies to make 12 and adds to make 8? 2 and 6. So y is negative 2 or y is negative 6. Then my y values, it's a simultaneous equation. I need x values as well. So x was 4 minus 3y over 2. So when y is negative 2, x is 4 minus 3 negative 2's over 2. And when x is negative 6, I've got 4 minus 3 times negative 6 over 2. So I'm just typing this into the calculator and I'll get my x value. So x is 5 when y is negative 2. And when I've got y as negative 6, x is 11. So on my answer line, I need to write my x and the y that go together. So x is 5, y is negative 2, or x is 11 and y is negative 6. And question 23. There are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3 to 1. So 3 parts red. So red to blue is 3 to 1. So that means I've got, well, 3 quarters and 1 quarter. 2 counters are removed at random. The probability that both counters taken a blue is 1/20th. Work out how many counters were in the bag before any counters were removed. So we don't know how many counters were in the bag, but we know if we take blue then blue, the probability is 1/20th. So the chance of getting a blue the first time, we know 1 quarter of them are blue, is 1 quarter. So the probability of blue then blue, the first one being blue, is 1 quarter. If we take a blue counter out of the bag, how many counters are left? How many are blue? So we don't know how many there were to start with. So we can say that there are x blue. So x blue and 3 times as many red. So 3x red, meaning in total there are 4x. The blue plus the red, 4x. So if we took a blue counter out the first time, there's 1 less now. So there's x minus 1 left in the bag. So you can think of this as a tree diagram. So it's blue or red, blue, red, blue, red. So there were x blue counters and 3x red. So the first blue counter, the probability, how many blue? X out of how many in total? 4x, which simplifies to a quarter. For the second one, if we take out a blue, we've got x minus 1 blue left and 4x minus 1 left in total. So the probability of blue then blue is 1 quarter times x minus 1 over 4x minus 1. And we're told that that equals 1/20th. So if we solve this equation, we can find out what x is, and then we'll find out what 4x is by timesing it by 4. So we've got 1/4 times x minus 1 times 4x minus 1 equals a 20th. So we can get rid of the quarter by multiplying both sides by 4, or we could times the fractions. It's probably easier to times both sides by 4. So if I do 4 times both sides of the equation, 4 times 1/4 is 1. So I've just got x minus 1 over 4x minus 1 on the left, and a 20th times 4. So 1/20 times 4 is going to be 1/5. Now I want to get rid of these fractions. So I'm going to times both sides by 5 and times both sides by 4x minus 1. So 5 times x minus 1 equals 1 times 4x minus 1, which is just 4x minus 1. Expand this bracket. 5 times x is 5x. 5 times -1 is -5. Then take 4x away from both sides. So x minus 5 equals -1. And add 5 to both sides. X is 4. So 4 times x is 4 4s, which is 16. So there were 16 in total to start with. So there were 4 blue, 3 times as many red, 12 red, which means there were 16 in total. The probability of getting a blue the first time was 4 out of 16. The second time, take away 1 from the blues, so there are 3 left out of 15 in total. 4/16 times 3/15, well, that simplifies to 1/4 times 1/5, which is 1/20. Here we have one more question. So I got to the end of writing down the topics and I realized I'd missed out iteration, so I've added a question onto the end of the paper. The number of people living in a town t years from now is pt, where p0 is 55,000 and pt plus 1 is 1.03 times pt minus 800. Work out the number of people in the town 3 years from now. So iteration is all about using our previous answer to get the next answer. So pt plus 1 is 1.03 times pt minus 800. So if we use t as 0 the first time, 0 plus 1 is 1. So p1 is 1.03 times p0, which is 55,000 minus 800. So this will tell us the number of people in the town 1 year from now. So we're substituting in the first one, substituting in the original, and we're going to get out our first answer. So 1.03 times 55,000 minus 800. Type it in the calculator and we get out 55,826. So 55,826. To find the number of people in the town after 2 years, we substitute in this answer. We substitute in the number of people after 1 year. So P2 is 1.03 times P1 minus 800. And on our calculator, we can use the answer button. So it's going to be answer 1.03 times answer minus 800. So let's type that in the calculator. 1.03 times answer minus 800. We get 56,677 to the nearest whole number. Or we could just write down the whole thing. So 56,676.78. And then we want the number of people after 3 years. And we substitute in this answer. But again, we can just use the answer button on the calculator, which will use this previous answer. So all we've actually got to do is press equals one more time, and we'll get our answer. So after 3 years, 57,553. We're going to give our answer to the nearest whole number, to the nearest integer, because it's a number of people and we couldn't have part of a person. So there is our answer.